Welcome to This Explainer. Today, we are going to completely dismantle how you process the world. Honestly, if you think you've got a firm grasp on reality, brace yourself, because we're about to reveal a totally mind-bending truth about how we construct knowledge. We're going to explore exactly why induction lacks a rational basis. And this isn't just some abstract philosophical puzzle. We're talking about the core algorithms of your own brain and the literal bedrock of all scientific discovery. I want you to start by asking yourself a ridiculously simple question. Seriously, think about it. Why do you believe the sun will rise tomorrow? Your immediate gut reaction is probably, well, duh, because it always has. But hold on to that answer, because by the time we wrap up today, that exact reasoning might completely shatter your illusion of certainty. Section 1. The illusion of certainty. Questioning our everyday assumptions. Let's dive right into the deep end by looking at those basic, everyday assumptions we make without even blinking. We navigate our entire lives expecting the world to behave in specific ways, completely trusting our past experiences to be a reliable guide for the future. Think about it. We expect the sun to rise every single morning. When we eat a piece of bread, we just assume it's going to nourish us, not poison us. When you turn on your kitchen faucet, you fully expect the water to fall downwards into the sink, right? Not shoot upwards into the sky. And why? Simply because that is what's happened in the past. We spot a pattern, and our brains instantly project that pattern forward. This incredibly natural, automatic process of projecting the past into the future is called inductive reasoning. It is the absolute bedrock of human survival. You literally wouldn't survive a day if you didn't use induction to, say, avoid putting your bare hand in a campfire. Plus, it's the fundamental engine of scientific inquiry, observing specific instances and then extracting general, universal laws from them. But here is the linchpin of it all. Every single inductive inference you make, or any scientist makes for that matter, relies entirely on this one massive underlying assumption called the uniformity principle. We just inherently assume that nature is uniform. We assume the rules of the game aren't going to just suddenly change overnight. But what happens if we actually demand proof for that assumption? Section 2. Hume's theory of knowledge, the empiricist foundation of David Hume. To understand why this seemingly obvious principle is actually a precarious house of cards, we've got to look back at the radical 18th century Scottish philosopher David Hume. Born in 1711 in Edinburgh, Hume was a staunch empiricist. At a time when plenty of thinkers believed humans were born preloaded with certain universal truths, Hume flat out denied the existence of innate knowledge. He argued that absolutely everything we know comes directly from our sensory experiences. For Hume, causal relations, cause and effect, are the only tools we have that let us step beyond our immediate memory and our present senses to make any sort of prediction. So, to systematically break down our beliefs, Hume introduced a brilliant concept that philosophers now call Hume's fork. He basically argued that all human reasoning can be sliced into two distinct categories. On the left side, we have demonstrative reasoning. This deals with pure logic and math, things that are absolutely 100% certain. On the right side, we have probable reasoning. This deals with empirical facts and the messy physical world, things we actually have to learn through experience. Section 3. The problem of induction. Why both types of reasoning fail us. Okay, get ready, because here is where the rug gets pulled completely out from under you. When Hume put the uniformity principle to the test using his fork, he showed that neither of these two types of reasoning can rationally justify our core assumption about reality. It's wild. Let's look at exactly why they both fail. First off, you can't use logic or demonstrative reasoning to prove the future. In logic, something is only guaranteed to be false if its opposite is a direct contradiction, like a square circle, right? But it is perfectly conceivable that the sun simply won't rise tomorrow. There is no logical contradiction in imagining a dark morning, so logic completely fails us here. Well, what about empirical, probable reasoning? You can't use your past experiences to prove that the future will be like the past, because doing that requires you to assume the future will be like the past. That is literally the very thing we are trying to prove in the first place. This brilliantly illustrates just how devastating Hume's conclusion really is. If we cannot find a rational basis for induction, the philosophical stakes are terrifyingly high. The legendary mathematician and philosopher Bertrand Russell later pointed out that if Hume's problem can't be solved, the line between rational scientific thought and absolute, complete delusion essentially vanishes.
Unsurprisingly, thinkers over the centuries have desperately tried to solve this. They really have. Some have whipped out complex probability models like Bayesian equations to mathematically calculate the likelihood of future events based on past sample sizes. Others argue that universal laws are simply the best explanation for the patterns we see, or they point to mathematical guarantees in model machine learning algorithms. But if you dig deep into literally any of these solutions, you'll find they all ultimately sneak in hidden empirical assumptions. They all quietly just assume the universe operates on consistent, predictable rules.
Section 4. The circular logic trap, attempting to prove induction with induction. The most natural defense you might have popping into your head right now is, but wait, induction works, science works, we built airplanes and iPhones using it. Which, yes, is true, but that leads us straight into an inescapable loop. Trying to prove that induction works by pointing out that it's always worked in the past is hilariously circular. You're looking at the past success of induction to predict the future success of induction. You are quite literally using induction to justify induction. It's like asking a known con artist to vouch for his own honesty. Some modern philosophers do try to soften this blow. They draw a very careful distinction between premise circularity and rule circularity. Now, premise circularity is considered vicious. That's when you just blatantly assume your conclusion in your opening statement. But they argue using an inductive rule to prove its own reliability, rule circularity, might actually be an acceptable or at least unavoidable way to justify a fundamental form of human reasoning. After all, you can't really justify deduction without using deduction either, right? Yet even with these clever defenses, we continually hit these massive mathematical and logical dead ends. Take the no-free lunch theorems in modern computer science. These theorems mathematically prove that purely data-driven algorithms cannot predict the future without assuming some unproven prior bias about the data. Without a built-in assumption, an algorithm does absolutely no better than random guessing. It's a narrative of repeated hurdles. Thinkers like Karl Popper tried to bypass this whole debate by saying science only falsifies theories, rather than confirming them, while others like John Norton argue induction just doesn't have any universal rules to begin with. Section 5. Living with unjustified beliefs, how to survive without logical certainty. So the huge question is, if we have absolutely no strictly rational, logical proof for our most basic assumptions about reality, if the bedrock of science rests on an unprovable leap of faith, how on earth do we get out of bed in the morning? How do we even function? Well, Hume's own resolution to his terrifying problem was psychological rather than logical. He essentially said, look, you aren't using logic to expect the sun to rise. You're using habit. We are simply wired by custom and repetition to expect heat when we see fire. It's a natural instinct, a quirk of human nature that keeps us alive. We're just creatures of habit living in a universe that, luckily for us, seems to reward those habits. Later philosophers basically just had to adjust to this humbling reality. Ludwig Wittgenstein argued that some principles are simply the hinges on which all our inquiries turn. They just don't need justification. P.F. Strawson argued that asking if induction is reasonable makes no sense anyway, because induction itself practically defines what it means to be reasonable in our daily language. And Hans Reichenbach offered a pragmatic view. Induction might not come with a 100% guarantee, but it is unequivocally our absolute best bet for navigating a complex, totally uncertain universe. As we wrap up this explainer, I want to leave you to ponder this one final thought. The sun will probably rise tomorrow. Your computer will probably turn on. But if the very foundation of science and everyday life is just an inescapable, unproven habit, a psychological trick rather than a rock-solid logical certainty, what does that truly mean for human knowledge? It turns out, simply living in reality requires a massive leap of faith that most of us didn't even know we were taking. Thanks for joining me on this deep dive.